Hello, I'm Jason with CodeLearner.com, and today we're going to continue learning about Java. Specifically, let's talk about what is Java, how does it work, and why is it important. And so, as we discuss what is Java, the most important thing for you to understand is that Java is a cross-platform programming language. What do we mean by cross-platform? Why is that important? What it means is that Java, you can run your Java programs on all manner of operating systems. So you can run your Java programs on Windows, Mac, Android, Unix, and there's also embedded devices, inside of smaller consumer electronics and so forth that also run Java. So it's a programming language that you can write and actually run it in great many different places, and that's why it's really so versatile. Right now we have Java code running on billions of devices, and those devices range from computers, like we discussed above, also, little consumer electronic devices that aren't full-fledged computers but need to run some sort of programming language. Java is a great choice for that. So when you learn Java, you're really opening a whole box of tools for yourself to address a large market. Now, when we talk about Java being cross-platform, we need to kind of take a few minutes to talk about what that really means. What it means is that when you write code, when you actually write your program, you write it in a text file, right, that you can read, and it has a .java extension. So here in the next couple slides, I really want you to remember this stuff, because as we go through the course, we'll be doing this stuff over and over again. When you write your code, it will be a regular old text file with a .java extension. These will be the instructions you really want to execute. Now, you do need to compile the code, and you compile it using a Java compiler. That's a freely available thing. I'll show you where to download it. So it needs to be compiled. Now, the output of this compile process is basically the compiler looks at your code and it assembles it into a .class file. So what you write is a .java file, and you just execute the compiler, and it outputs your program in terms of a .class file. So if you look at the files, one of them will be a .class file after the compile process. Now, the .class file is called bytecode. That's just something I'm trying to teach you because it's interesting for you to know, and you might read about it in books somewhere. It's called bytecode. It's machine readable. So in other words, the .java file that you write, you can open it in a text editor and you can read it. It's going to be like words and symbols, in a text file. The .class file, after the compile process is done, is going to be something that you're not able to read. It's something a computer is able to read and interpret. So this translation process from this file to this file is called compiling the program. That's what that's called. Now, the .class file can run on any system with what we call a Java virtual machine. Now, here's where we get into some of the terminology. I'm trying to make this easy for you. Java virtual machine, it's a big fancy word. Basically what this is a piece of software on your computer that lets you run Java programs. So all modern operating systems, they're going to have a Java virtual machine available. So Windows has one, Mac OS has one, Unix has one, so even Android devices have one. And so you need to have this Java virtual machine in order to run your actual program. The class file that's generated is what is actually run by the Java virtual machine. It's what's interpreted. So the whole process kind of goes like this. You type your code into a .java file. You compile it using a compiler. The output you get is a .class file. This is what the actual program is. This is what you want to run and actually execute the instructions and run the program. But you have to have a Java virtual machine in order to run Java programs. Java virtual machine looks at the class file, and it actually goes line by line through there, and it executes the binary code in the class file. And when we say it's interpreted, that's all that we're saying, is that virtual machine just goes line by line and looks at the instructions and executes the output. So in the previous slide, we talked about how you compile a Java program, what you get as an output, and basically how you run it. The Java virtual machine is how you run the program. But I think a picture is worth 1,000 words, and so we're going to summarize that process right here. This image here is exactly what we said on the previous slide. It's just written in terms of a block diagram, which I think is easier to understand sometimes. So what you have over here on the left is what you type in. This is you sitting at the computer screen typing in your code. Everything that you want this program to do, you have to type it in there, and it's in a Java file, a .java file. So you might name it iloveapples.java if you're writing a program about apples, right? So you take this text file and you run it through a Java compiler. This is a program that looks at the file and crunches through it and outputs what we call that bytecode, which is a .class file. So if your file name was called iloveapples.java, then the output is going to be iloveapples.class. That's the output of the compile process. Now this orange block right here is really the program as it's ready to be run. But you can't just run Java programs by themselves. They have to run inside of a Java virtual machine, which almost all modern operating systems has. And if you don't have it installed, it's freely available. So this Java virtual machine looks at the bytecode file line by line, interpreted, and it executes your program. So here we have a computer saying "Hello world." This was typed into the source code here and goes through this process there. Now, many of you guys have come from learning about C or C++, and so I'd like to kind of compare this Java process a little bit to C, just so you can understand the differences. So when you're writing C code or other compiled program languages, you type the program into a file just like before. This is a text file, and you run it through the compiler just like as we have written here. Now the difference is right here. When you run it through a C compiler, you don't get a bytecode file. You get an executable file, .exe. So you may have heard, like in Windows, for instance, it's iloveapples.exe. Now this file would be ready to run on Windows. I would double click this file and it would run. I don't need any kind of virtual machine. I don't need any interpreter. When you compile a C program, it's ready to run on that system. So as soon as I run it, here's our computer running "Hello World." Now at first glance it might look like this sequence down here is shorter and simpler, and so wow, I really want to learn C++. That's really, something looks like it's easier and shorter. I really want to learn that. There's a huge difference between this process, and I want to spell that out for you right here. For C++ programs, you need to compile them, which is this step, for every single system you want to run in or run on. So listen carefully, because this is the point I'm trying to make in this slide right here. If you're writing C++ code and you want to write a game, let's say, you want to write a game for Windows, and you also want to be able to run it on Mac, and you also want to be able to run it on Unix, and you also want to be able to run it somewhere else, then you need to take this file here and you need to compile it. You need to have a C++ compiler for Windows and compile it for a Windows exe. Then if you want to run it on Mac, you have to go take the same file and compile it again using a Macintosh compiler. So you have to go compile it again on Macintosh, and then you can run it on Macintosh. And then if you want to run it on Unix, some server somewhere, then you have to go compile the whole thing again using a different compiler for that Unix workstation, and you get another executable code for that workstation. So every single platform that you want to run this thing on, you have to go compile it again. And you have to have a specific compiler for that operating system. And that's a real pain, because if I'm running a game, there might be small differences from compiler to compiler. So I may have to go change some things in my files and get it all to work right. So it looks like this process is simpler, but in reality it's kind of a pain, because I have to go compile it for every single platform I want to run it on. Now Java really is the huge benefit of Java is avoiding this whole problem. In Java, I can write my code only one time on my local computer. Let's say I run on Windows. I can write this code and I can compile it on my Windows computer. Now this .class file, this bytecode, is able to run anywhere on Mac, on Unix, on Windows, on other platforms that have a Java virtual machine, and almost all modern platforms do. So I could literally take this class file and I can email it to my friend who runs on Mac, and he can run it. And then I can email it to my buddy who runs a server, and they can run it, as long as they have a Java virtual machine, which is ubiquitous. They're everywhere, and all platforms have them now because Java is so popular. So this is the main difference between Java and between other compiled programming languages. You can write it once and you can run it anywhere, which really is my next slide. The main benefit is you can write the program one time and you can run it anywhere. You write the code on your system, you compile it one time to a .class file, and then I can email this file or send it off on a disk to any other number of systems out there that I want to run it on. I can put it on the internet, so you can download it from Mac or Unix or Windows, and this .class file will run anywhere. And that is the main benefit of Java. So in this set of slides, we really just wanted to introduce what is Java, how is the program compiled, and I really want you to go back and study this a little bit. Don't memorize it. Just try to be familiar with what we're doing here, because in a few minutes we'll take our first program, we'll compile it, we'll get a .class file, and we're going to run it. And I really want you to understand how that works. So follow me on to the next section, where we will continue talking about this, inching our way forward, compiling our first program so that you can really understand exactly how everything works.